All right, so my presentation is on ISO8583, or how to pen test when given a target that is not your normal target. Give a little bit of who I am. Worked in the IT industry for 15 years, last 6 years in InfoSec. Currently work for a large financial institution. Since this isn't sponsored by them, you can catch me later and we'll talk about it. Amateur lockpicker, avid gamer, nerdcore rap, and dubstep, and part-time zombie. You guys will love that. Your makeup better be really good, Valerie.
It will be.
All right. So essentially the agenda, I'm going to describe the scope of the pen test that I had. Intro to ISO 8385. Warn you, it's almost like reading an O'Reilly book. You ever read an O'Reilly book? If you're an insomniac, that'll cure it real quick. Different steps that I took to try to communicate with these systems, and then detail out the final solution, which is Python saves the day. Thanks, Bob. So the scope of the pen test, it's fairly simple. We had a normal network pen test. You know, you grab your network scans, your qualia scans, analyze the ports, look for vulnerabilities, do a little research, find out what's vulnerable in those areas, what's not. Try to penetrate those systems, see if you can exploit those or not. And then the second task I was given was to successfully communicate with an ISO, and I mistyped out the previous one, didn't I? 8583 system.
Also, that should be of pen test for your management presentation. Fix that one.
So what is ISO 8583? Well, a lot of people when I've gone to these cons have talked about obtaining the magnetic stripe data on the card from off the POS machine, from off the card itself, and that type of thing. You ever wonder what happens behind the scene, though? How the actual point-of-sale machine or the ATM or the merchant talks to the acquirer or to the bank. And what's generally accepted is to use the ISO 8583 standard. Now it's called standard, not a protocol. It's also otherwise known as the Financial Transaction Card Originated Messages. Big, long name. So the card-based transactions generally travel from the point of sale to the ATM to the card issuing system, and then from there to the bank and the acquirer. That contains your PAN, primary account number, terminal merchant transaction information, the amount, you know, who you purchased from, information like that. ISO 8583 defines the format and communication flow so that different systems can exchange this information and either authorize, decline your card, etc. So there are three main components to the ISO 8583. There's the MTI, the message type indicator, that's about 4 bytes. The bitmap, now that's a binary bitmap showing which data fields are being sent. Generally, it's 64 to 128 data elements. Newer revisions, you can go up to 192 data elements can be sent. And then the actual data fields, which this contains the actual data, the primary account number, your name, you know, the track 1, track 2 data, all that, the terminal, point sale, etc. So we'll break down the MTI a little bit. In the MTI, each position in the MTI tells you what's going on with it. So the first position is the ISO version. As you can see, there are 3 different versions right now, 1987, 93, and 2003. And it's just the different formats or how long or how many data elements you can use depending on what version. Most of them I've seen are using the 0, the 1987 version. We'll move on to the second position, which is the message class. Now this is where it gets a little, I guess you could say, important. The first position, if it's a 1, it's an authorization message. So it's asking, hey, can we charge this account? Second one is a financial message, a 2. If it's a 2, this is pretty much saying they want to post directly to your account. A lot of times this is like an ATM or that type of thing. 3 is for file action messages. Never seen how this is used, I apologize, but as you say, it's used for hot card, TMS, and other exchanges. 4 is a reversal, so you go in, you buy that thing, and you decide, you know, your wife tells you you can't, or your husband tells you you can't have it, so you got to take it back. This is the reversal. 5 is a reconciliation. Transmit settlement information message. In the second position, if it's a 6, it's an administrative. Usually for just failure messages or rejects, failure reply to figure out what happened, or annotate the account or find out why. 7 is a fee collection. And the interesting one that I got to play with a lot is if it's an 8. Now these are network managed messages. These are kind of the check-in, check-out, log-on, log-off type messages with these. And then 9 is reserved by ISO. It's not really used yet. Third position is the message function. So if it's a 0, it's a request. A 1 is a response. 2 is advice. 3 is an advice response. You see a kind of pattern here. 4 is a notification. 8 is a response acknowledgement. And 9 is a negative acknowledgement. I'm going to go into the fourth position here. And this is the message origin. Most of the time you'll see zeros at the end if it's being sent from the point of sale or the acquirer, which means that's it's the ATM or the point of sale machine or the acquirer sending the message. A 1's a repeat if they don't get an answer within a set amount of time. I do believe, according to PCI DSS, it's 7 seconds, I think, you have to get a response in right now when you make a request. 2 is an issuer, 3 is an issuer repeat, 4 is other, and 5 is an other repeat. So then we go through some really fun stuff here. Here's a few examples. So essentially, if you go to purchase something, normally what will get sent through is a 0-100. And it's asking the bank, hey, does this person have any money in his account? Can we charge his account? And what they'll get back is a 0-110, coming back saying, yes, no. There's also a 0-200. That's normally for ATMs or a PIN point of sale. That's probably more popular, especially with chip and PIN over in Europe, where they're saying, hey, because we have a PIN response in here, and then you get a 0-210 to come back on that. The other kind of fun one I like looking at is the 0-400. That's another one that you'll probably see a lot of is acquire. Well, that I saw a lot of is the acquire reversal request. And that's if you just want to reverse out the funds, i.e., you purchase something, you come back and you decide, you have buyer's remorse or whatever. And then the really interesting one is the 0-800, and this is the echo test log on, log off. Essentially, for these machines to stay connected to the ISO8583 systems, they have to, within a set amount of time, keep resending the 0-800 message. And essentially, all you send then is you kind of send like a time of day request. So you send a 0-800 and you say, hey, I've got, here's today's date, what time you got? And you get the 0-810 back saying, well, I've got today and I've got this time. And it's kind of its way of staying logged onto the system so that you know that you've got an open communication with the system at that time.
It's just to keep alive.
Keep alive, essentially. But it does have to keep refreshing that within a set interval, and it's all dependent upon the back-end system, what they require. So then we get into the bitmap. And the bitmap was really, we'll say, fun piece to tear apart. Because as I said before, the bitmap is a file or subfield showing which data elements are going to be sent. Now these data elements, you can have up to 3 bitmap strings. And you can have data elements 1 through 64, or from 65 to 128, and then all the way up to 129 to 192. Now, generally right now, only the primary and secondary bitmaps are used for most card data right now. I am not sure why they need 192 data elements myself. Most of the time it's in 8 or 16 bytes of hex data. Now all this is telling you though, and you can see how I kind of broke down an example down below, just the hex strings that you have there. It's telling the system what fields you're sending. Now generally you're going to send at least the track 1 and track 2 data off the card for the person. So you're talking about your card number that's on there, your name, and any other information that's on those tracks. And then also you're going to send the terminal ID, who the merchant or the acquirer is, or even an ATM number if they have they have set up numbers and designations. Time of day, when the transaction was done, the amount, of course, and that type of information. And you're just defining those fields within this. The very bottom one, I don't know if you guys see it down there or not, that's actually doing a primary and secondary bitmap. And a lot of times that very first field, if it's on, or or 8, that usually tells the system that not only do I have 8 bytes of hex data, I also have an additional 8 bytes, which is the secondary bitmap. And that's how they flag to tell whether you have just one set or 2 sets of data coming through on the bitmap. This is where it gets real fun. So to make it a little easier on me, I created an Excel spreadsheet. Now I know this might be a little hard to read, and I apologize for that. Showing all 128. And then if you just figure it out, put the little ones and zeros in there, because it's binary data that's converted to hex that's sent to the system. And it's a very long string, and that's just an example one where I pieced it all together, and then, because I suck at converting binary to hex without a calculator. So then now we have the actual data elements or the data fields that we send. These are the individual fields that carry all the information that you told it in the bitmap that you're sending. Now in the ISO8583 1987 standard, there's 128 data elements. And like I said, in later releases, you can have up to 192. And each one has a very specific meaning and format, even within that. So just to give you a very idea, on the next table you'll see each one of the contents of the field could be either numeric, binary, alpha, special characters. Some have special encoding that you can use depending on what fields you're sending. And now this is all defined usually by the bank or the back end or the card or the issuer. And most of this information they give out to, say, the acquirers or the banks who are sending these messages through the system. They have pretty much large, boring documentation that I read through to figure out how to send this information. Now, unfortunately, I could only fit 21 fields on here for an example for you to see. But as you can see, normally, like the first field is a bitmap, and it's telling if the second 128 bits are present or not. The second field, of course, is your PAN, your primary account number. This can be up to 19, and it's numeric. And by the end of 19. Processing code, the amount of the transaction, etc. You can kind of see up there. I'm not going to read it off to you. And some of the other information, it's amazing all the data that they try to capture or say that they can capture in just a transaction. You think about that now, 192 data elements, varying length, alphanumeric, special characters, has to be sent and a response returned within 7 seconds, I do believe is what they're saying. That's a lot of data. And most people, though, you swipe your card and you got to wait there a few extra seconds. You're hemming and hawing and going, what's going on? And a lot of people don't realize in the back end there's a lot of information going through.
Sir?
Yeah.
Go back one.
Sure.
If 2 is the PAN.
Yes.
What's the 3 or 4 digit number on the back of the card, and what's the name on the front, and what's the expiration date?
So expiration is 34.
Yeah, date expiration is 14.
Or 14.
Date settlement, date capture. There are a lot more fields. Like I said, there's 192 elements. So I only captured just a quick top bit to kind of give you an idea of what all you're sending. But all of that is included within. And sometimes even in the PAN, as you can see, it says 19 digits. I don't know, are there any 19-digit credit cards right now? But if you add a CVV on the end of 16, 3-digit, you have 19.
Yeah.
So then we can start going over a little bit the different ways I tried to communicate with the system. Now, so I was pretty much told, okay, you need to successfully communicate. So I did a little Google is your friend, searching around, and I came across JPOS. Now this is a Java-based framework for sending ISO8583 messages. All right, cool, this should work. I've got Java on my system, who doesn't? Essentially, it's a framework, so if you have a point-of-sale system in your store that you can put together, and you process, first you have your merchant ID, et cetera, and hooked up with your bank. And you just set it up on your system, and it's going to take everything that you input into it, format it in the correct string, and send it through to the bank for you. Unfortunately, I'm not a Java developer. No clue on how to get this working right on a normal just pen test trying to send a simple message across. So I thought about it, oh, let's go back to all my pen testing training and we'll go to Netcat. So you can pipe files through Netcat. So I said, all right, the pen tester Swiss Army knife, we can do that. So I created a text file, and as you can see, I created a 0800 message and showing my bitmap and the fields and the different information I'm going to send to it. And I said, all right, I'm going to netcat to 1234. No, that's not the IP that I used. And to a port, to a specific port to communicate with the system. And I inputted the file. But this method failed. And I'm like, what's going on? I wasn't getting any responses back. Tried it 3 or 4 times. Ended up talking to the sysadmins on the back end. What's going on? What are you seeing? And on this part, on the next one, on the next bullet point, TCP dump of the communication. On all my pen tests now, when I do anything, I run either Wireshark, yeah, I know that's Windows, or TCP dump or WinDump while I'm performing a pen test. And the reason I do this is, so number one, so I can see exactly what I'm sending and what response you're getting back. Because sometimes in whatever you're doing, you might not visually see the response, but there might be something coming back across the wire that you don't see. And when you capture these data packets, you can see what's going on in the back end. Also, too, if they come back and tell me you did X, Y, Z, I can kind of show them, no, I didn't do that. This is what I did. That type of thing. So what I discovered looking at that, and also working with the back end system, Netcat adds 2 bytes at the beginning of the communication. And the ISO8583 system interpreted that as the size of the message I was sending. And since it didn't match the message size, they rejected it automatically. These systems are very sensitive how they'll accept the message. If it's not formatted perfectly, it drops it, it rejects it. And I can kind of give you a little bit there on the PCAP if you can see it. Essentially, it sent a 3038 at the very beginning of the message and said I had 12,344 bytes. So you can see at the bottom there, I only had 70 bytes in that message, in the actual data. Tried it several times, and it's just part of Netcat.
So did it reject the message, or did it just not respond?
It rejected the message.
So
Well, I actually didn't get a response back. It just dropped it. It dropped the packet, essentially. So that's why I was kind of stuck there, because I sent this a few times. I'm like, not seeing anything come back. What happened there? So, all right then. So I spent a couple more days on Google, my friend, saying, all right, how does everybody else talk to ISO8583? Several programs out there. Of course, there's plenty of shrink wrap packages out there you can buy. Couldn't get that approved. I don't know why. None of which really met my needs either. All I needed to do was just simply communicate with this system and prove that it could be done. And then I remember, tooling around and watching some different Python coding people did, that somebody created a straight TCP connection with Python. I said, So I started doing a little research on this and looking at what I needed to do in order to create a TCP connection with Python. So the final solution found, as I say here, Python to the rescue. So I created a Python code where I defined the different parts of the ISO8583 message. Of course, used Python to create a TCP socket connection. Piped all that hex code, the message length, the MTI, primary, secondary bitmaps, all the data elements, and I received a successful response back from the system. And then from there, I was told, you're done. Essentially, they didn't want me reversing all the charges off my own card at that time. I'm not sure why. Of course, everybody else too, my team was like, oh, you were able to communicate? Hey, if I give you my card number, yeah, okay. Might be a little hard to read, and I apologize for this. This is essentially the Python code that I use. Now, I don't know if anybody's ever heard, well, I'm assuming some people here program in Python. The interesting thing is the first time I tried this, I took all those hex bytes, all those fields in the beginning, I made a huge string and tried to send it, and Python said, no, you can't do it that way. So what I found is I had to break it up individually, and then also I found it was a little hard to manage. It's storing a whole long strings of X slashes and trying to figure out, wait, okay, well, I want to change this field or that field, or I need to change the date and the time, and where was that in that big long string? And I said, you know what, no. So I ended up breaking it apart. As you can see, like the length, field at the top, the MTI, 303800 at 0800. Then the bitmaps defining what fields. And of course here I show field 7, 11, 32, 70, 100, 127. There's some links at the end. If you want to go up, you can look up each one of those individual fields and what they represent. Most of them were pretty much date, time, who I was. I just made up a merchant number. So because I was doing a pen test, they did kind of open it up and accept messaging from me. And I'll talk about that a little bit. Essentially, then I just strung the whole message together and sent it across the wire. And then I opened up a port, waiting to receive, see if I get a message back. See if I have that here. So essentially, if you could kind of see in the blue there, the big part to see is the 0800. Is me sending my message across. And then the next reply to that is the 0810 coming back. And essentially all that was the log on message that I was sending them saying, all right, I want to talk to you, I'm logging on. 0810 is coming back, good. You know, here's the time of day you sent me, here's the time of day I have, and you're connected. So kind of in summary, you know, to summarize the pen testing and your not normal target, and giving you, now that everybody knows how the back end of when you swipe your credit card works now too, is of course I was able to find plenty of information on how it worked. ISO8583 is out there all over the internet. You wouldn't believe how much information is out there. Of course not, you know, Visa of course was the beginning of it all, so anything you want to know about them is out there too, and anything they do. But the next step of actually communicating with the system was, as I said, another journey. Once I was able to establish communications, I was pretty happy. I wanted to do some more stuff. Of course, that wasn't within the scope of the pen test. The big thing here, I came back with this, is that I found that it's helped reinforce everybody else's talk that they've talked about knowing some type of programming language or a scripting language will help you in pen testing. Whether it be just you know, doing batch files, VB script, bash, all of that, or you know, JavaScript even. I really did enjoy this pen test. I spent a lot of time looking at packet captures. If you've ever done that, you can go cross-eyed very easily, very quickly. And I was even able to expand my Python skills, and that's something I've always, you know, been working on, still working on, and enjoy. Here are the links. Of course, Wikipedia, and a few other links. I'm not sure they're going to have these out there or not. If you guys want these links, you can hook up with me, and I'm glad to share them with you. A lot of information out there on ISO 8583. A little bit on it though is each issuer, each bank can have their own specific ways they need information sent. So it's not, even though it is a standard, I'd say it's not. Only for the reason of they can change, you know, they can say, send us the primary account number. Well, do you want it straight in binary, you know, hex converted numbers from a, you know, a 3 to whatever that, you know, the hex equivalent of that is of a 03, or do you want the ASCII representation of a 3? I found out. Each acquirer has different requirements. Now what's interesting about that is if you do enough Googling, you can find the documentation out there for most of the card issuers. Most of this documentation they give to the acquirers and the banks when they want to set up an account with them for them to send the information back and forth. That's pretty much it. Any questions? Sure.
When you did your pen test, your target of that IP address, was it the point of sale Windows embedded system at a store? Was it what was your target that you first of all, and second of all, how did you sniff the wire? Did you put a hub in place? Was it wireless?
So actually I worked for the large financial institution that I was doing this pen test for, so you could say I kind of had an inside already. Getting on these networks was a very lengthy and hard process for good reason. I know you kind of mentioned earlier, oh, this is messaging going over the internet. It's not actually going over any public internet that you can find out there. And there's good reason for that. People like us would be in it all day. So you could say I kind of had an insight on this because I did work for the company, so I was able, and I was talking to the actual issuer back end. Sending these messages. So essentially I was acting as an acquirer. So I was playing as I'm Walmart or Target or one of those big, or global payments, even though I wouldn't want to play as them right now, they're in a lot of trouble. One of those type of people, and I was trying to send a message and get a response back.
Does it go over like frame relay or?
Unfortunately, I don't know, and I'm not going to. Even if I did know, I probably wouldn't give out the secret sauce there. It's a private network. That's
They're basically dedicated lines at that point.
Yes. You do enough Googling out there, you'll find out. And this is the harder side to get into if you do. As the evaluation of this pen test, even though I was able to communicate and a lot of things I did find, there was enough mitigating controls around it that, okay, fine, we understand that if someone, I think it was a list of about 6 to 8 different conditions would have to be met before we would have to worry about somebody actually creating code and talking to the system on the back end. And I really hate that I can't catch me offline, buy me about 5 beers, and I'll probably tell you that. So, any other questions? All right.
Did you ever try DOSing it, like we talked about? Stick it in a while loop, infinite loop, and just see if it works?
Just so everyone knows, this is Chris up front here asking this question. He's actually was our intern this summer where I work. So, and he helped me out with the pen test this year on this. Yes, I did. It does have a rate flow.
Yeah.
Also, too, I did get a nasty email.
Really?
Yeah. A lot of this I worked in a development environment. If anyone's ever done, pen tests on highly sensitive systems, a lot of times they tell you, you know what, you can go over here and play in the dev environment, that's fine. Even this dev environment is highly monitored. If anyone's ever broken a production system, you understand that sensation. It's great. No one's ever done that, right?
My pen testers were blamed for a system swapping over this time, and it turned out it was a hardware failure. I lost 2 days of pen testing while they were figuring out a DIM went bad.
Been there, done that. Any other questions? No? Cool. Well, thank you very much. I will tell you, my very first presentation on a large con, so